All right, this is lesson 23, example problem 3. So for this problem, we want to find the moment of inertia of a rectangular block that has a hole missing in the middle. Right, so just like with example problem 2, we're going to break this up into finding the moment of inertia for the rectangle and then finding the moment of inertia for the circle, and then we're going to subtract the two from each other. So we're going to start with our rectangle. We're going to say that the moment of inertia about the centroidal x-axis is equal to the base times the height cubed divided by 12. So again, if we're looking about the x-axis, then the base is going to be that 100 millimeters that goes along the x-axis. The height is going to be the 150 millimeters that runs parallel to or perpendicular to it, and then divided by 12. And that'll give us the moment of inertia about the centroidal x-axis is 28,125,000 millimeters to the fourth. All right, so next up, we're not rotating about the centroidal x-axis, we're rotating about the given x-axis, so we have to use the parallel axis theorem. So the moment of inertia is equal to the moment of inertia about the centroidal x-axis plus the area times the distance squared. So that's going to be our 28,125,000 millimeters to the fourth plus the area, which is going to be 100 millimeters by 150 millimeters. And then the distance of that shift is 75 millimeters squared. So we go through all that and we get the moment of inertia for the rectangle about the given x-axis is 112,500,000 millimeters to the fourth. All right, so next up is we look at our circle, and we can see that the moment of inertia about the centroidal x-axis is pi times the radius to the fourth divided by 4, so that gives us pi times 25 millimeters to the fourth over 4, which is 306,796 millimeters to the fourth. And again, use the parallel axis theorem to find the moment of inertia about the given x-axis. So that'll be 306,796 millimeters to the fourth. The area for the rectangle is pi times the radius squared. So that's pi times 25 millimeters squared, which is 1963.5 millimeters squared. So 1963.5 millimeters squared. The distance that it's moved, again, is 75 millimeters squared, giving us a moment of inertia for the circle of 11,351,458 millimeters to the fourth. So while in the previous problem, we had shapes that were adding together, you can equally do it by subtracting. So our overall shape is a rectangle, right? And it's missing a circle in the middle. So easy enough, we say overall the moment of inertia of our object about the x-axis is equal to the moment of inertia for the rectangle minus the moment of inertia for the circle. So that gives us 112,500,000 millimeters to the fourth minus 11,351,458 millimeters to the fourth, which gives us 101,148,000, 542 millimeters to the fourth. All right, so if we want to make that number look a little better, we can do a unit conversion, right? So every 10 millimeters is 1 centimeter, right? And we're converting millimeters to the fourth to centimeters to the fourth, so we have to do our unit conversion to the fourth power. So if we do that, we end up with 10,115 centimeters to the fourth as our moment of inertia about the given x-axis.